Okay, thanks for joining us, everyone. It's the July community call already, and the year is going quite quickly by. Let's jump straight in a minute before I get onto the second agenda point here to something which isn't on the agenda. I forgot to add. Just recapping the recent SingularityCE release. About 2 weeks ago now, we released SingularityCE 3.11.4. So this is a patch release in the 3.11 series, and I'll just highlight some of the changes that came out in this one. The first one was a change default for handling overlay mount points, which we pulled in from the Obtainer project, which basically uses a different mount option if it's available in order to fix a consistency issue if you happen to have cache flushing going on the system that you're using. And that's unlikely to be hit by many people, but it is a fix, and it's marked up as a change default or behavior here because it is making use of a different mount option. So we do have a change there behind the scenes of how Singularity is interacting with this system. In the new features and functionality on 3.11.4, although it's a patch release, we've got a couple of new things added which don't cause any kind of backwards incompatible breakage. The first thing is that because we pull in the plugins from the CNI project, we've now brought in a new one with a new version. So there's a new tap plugin. And if you're configuring networks for Singularity containers, you can now define networks that use that tap plugin. Second point here, remote get login password is a new sub command. So get login password on the remote main command. And what that one does is if you're interacting with Singularity Enterprise or the Sylabs Cloud in your versions where there is an OCI registry behind the scenes, you can now retrieve a CLI token so you can interact with that from OCI tooling. So you can kind of grab a token which will allow you to authenticate with things other than Singularity by using this command. We have a new flag called no set groups for fake root builds and when you use run, shell, and exec with fake root. So the description here is a bit kind of wordy, but basically what this means is that when you're in fake root mode or fake root build, if you use no set groups, the container will be able to access files from the host system that are dependent on supplementary group membership. So if you've got a directory on the host system and you can only access in there because you're a member of say a project group or a laboratory group on some university HPC system, by default, fake root mode kind of blocks you getting in there because we have UID and GID mapping in a user namespace, and we reset the group membership when we enter the container. No set group stops us resetting the group membership so that out on the host, we can still access the files which require a supplementary group membership, but still in the container, because of the limitations of user namespaces and ID mapping, you can't properly use the supplementary groups. They'll appear as nobody. You can't change your group or new group to them, but you can kind of access things out on the host. This will be easier to kind of understand if you try it out. Have a look at what happens when you access things that use supplementary groups with or without the no set groups flag, and you'll see what it does and whether it's useful to you. We had a community contribution, which allows you to set an environment variable Singularity configure. And this kind of changes where Singularity stores its per user configuration. So the .singularity directory in your home directory, you can kind of move it somewhere else. If you really want to kind of put it in a standard place, like the XDG directories, you can now do so by setting Singularity config dir to that. Or you can move this directory off onto an alternative file system if the cluster you're using would benefit from that. On the bug fix front, we have some fixes on the OCI mode for a couple of embarrassing really problems where we had unprivileged overlay use blocking OCI mode on systems that don't support it, and also an incorrect wire up of standard input to containers. So those things are now fixed in the experimental OCI mode. Omers, who's on the call, dug around a lot and fixed an interesting problem where in definition files, N characters, so the letter N, was being dropped from definition files when they were stored in the CIF metadata. So if you did a Singularity inspect of a container built on these certain platforms, you could have a definition file come back, but missing some N's, which were in place in the original one, and that bug has now been fixed. Compilation of 32-bit systems has been fixed for an issue introduced with the instance stats code. So if you're using Singularity on a Raspberry Pi using the 32-bit Raspbian, you can now compile again successfully. We also have another kind of compatibility fix here to remove a non-POSIX operator in mconfig, which can also cause problems on certain platforms when you're trying to build Singularity. Final two ones in the middle here, there's a fix that will allow certain operations to complete properly in fake root containers. This was pulled from the Aptainer project when they discovered that new versions of GNU Make, which try and create pipe or socket in temp could fail. And then we also have a fix where unprivileged proot builds could freeze when copying files between stages. So the cause of that was found and fixed too. It's probably enough of me talking about what's in that release. Does anyone have any questions on that before we continue? Okay, as usual, if you get this release and you find any issue, please do report it on the issues page. And if you have any questions, highlight again in this call that we're now using GitHub discussions as a place for asking questions, suggesting things, ideas, roadmap discussion, and so on. So I encourage you to kind of ask any usage questions there if they don't fit the issue templates. Right, having done that release update portion, we'll go back to the actual agenda as written down. And I'll hand over to Adam Hughes, who's going to talk about the OCI CIF work. This is our work towards Singularity 4.0, where we will be encapsulating OCI containers into single file CIF images, where it's true encapsulation of taking the OCI image and kind of preserving it, rather than translating it into a Singularity format and putting in the Singularity specific stuff. So I will stop sharing and I'll hand over to Adam for this part.
Thanks, DT. It doesn't look like I'm able to share my screen. Oh, there we go. All right. So yeah, so starting to talk about the OCI CIF encapsulation. Kind of tough to talk about because there's not a lot to visually show yet. This is still down at the developer level of how we encapsulate this, and the work that is out there today is really focused at that level. DT and Omar are working to integrate this into on the path to 4.0, but I think it's worth getting this out there and getting hopefully some early feedback on it as we go through it. So in order to kind of tell the story of what we have out there in on the path to 4.0, I'm going to start with this package from Google called Go Container Registry. Super awesome Go package, and even has a great picture of what an OCI image actually is under the hood. So for some of you, this might be a refresher. For others who aren't intimately familiar with what an OCI image looks like under the hood, this will hopefully help frame where the work we've done fits in, and how it integrates with the existing OCI standards. So if you've ever run a Docker image, Alpine or whatever it might be, usually what you end up pulling first is something called an image manifest. And an image manifest is really, exactly what it sounds like. It's a manifest of everything that's inside that container image. Behind the scenes, that's actually generally pointers to just two types of things. One is the configuration. This is, if you've ever done a Docker history, the history is stored in there, and then really the configuration for how to run this container is in there. And that's kind of metadata that a runtime like Singularity or Docker can use to know how to properly execute that container. And then really the only other thing that is in a container image is one or more layers, and these make up the actual root file system in their entirety. So both the configuration as well as the image manifest end up pointing to all the layers. So on this diagram on the right here, this image would have 3 layers, and the manifest obviously points to that as well as the configuration. And then somewhat more recently than image manifests, image indexes were added, and this is to solve the problem of when I do Docker run Alpine and I'm on an x86 system versus an ARM system, how does it know? Obviously, at the very right here, these layers have to be different for different architectures, but at a user level, you want to just be able to say run Alpine and have it work. So what happens under the hood, and this isn't super visible if you're just at the user level of Docker, is you actually end up pointing to an image index. And an image index is really just a list of image manifests. So the typical use case for this is exactly what I described. You'll have an image index that has often 7 or 8 different architectures, depending on what the publisher has chosen to support. And then your system is smart enough to look at that, know what the architecture running on is, and pick the correct image manifest. From there, it operates just like it used to with an image manifest. So that's kind of how it works under the hood. The reason this Go module is very useful to us is it sort of forms programmatic constructs for these different concepts. So V1 image is really what we're talking about when we talk about that image manifest from that diagram. So this is kind of an image that you can run. Image index is the list of images that on the very left of that diagram we looked at, and then V1 layer is the actual root file system layers that make up the image. So with these, you can see in this module there's different implementations for these. So from this package, I can pull an image or an index from a remote. So this is pulling from like a Docker Hub or Singularity Enterprise or even SCS now from our OCI endpoint. And there's others. I can pull directly from a Docker daemon. I can pull from an OCI layout that's on disk. And then there's also this concept of syncs for being able to write out, given an image, being able to write it out either to an OCI registry in this case or any of the other destinations here. So that's kind of work that's out there already in the world. And now I'm going to flip to some Sylabs code that's sort of using these abstractions but mapping it to the Singularity image format. So this is a relatively new repo we put out there. This code might not end up living here for the long term, but at least while we're in this kind of very rapid evolution phase leading up to 4.0, this is kind of the spot where all the OCI related tooling related to SIF and manipulating OCI images is living. So the first one I'll jump into here is SIF. this, is a really simple package. There's not a ton in here. But basically this implements, the source and sink for, it's actually for image index. So here you can take, an image index and you can write it out to a SIF at a given path. So this will, if you, let's say over here, you take an image from a remote from the registry. Once you have that, you can then programmatically write that out to a SIF file using this. So in I guess moving up to 4.0, if you do Singularity build docker :/alpine, with this, you could potentially end up with a SIF image that has the exact layers and config and manifest from the OCI registry directly embedded within your SIF. And then the image index from file image, a bit wordy. This does the opposite. So given an open SIF image, it allows you to get an image index out of it. So these are kind of the counterpoints. One allows you to write OCI encapsulated SIF image, and the other allows you to then get those OCI artifacts back out of a SIF image. So that's that's there. That works. But obviously there's more to running an OCI image in Singularity than just this. In version 3.0, one of the things that we do if you convert or you run an OCI image with Singularity is that we convert the layers down to a single layer, and then we use a different format. So the OCI standard uses tar for each layer, the tar format. We convert that to a SquashFS format. If you've ever looked inside a version 3 SIF image, you'll see, there's a few different sections, but the biggest section is actually a SquashFS file image, which has in it the entire kind of squashed root file system. So the other package we have in here is sort of to bridge that gap of how do you get from a multi-layered tar image into an image that has a single layer and is in that SquashFS format. So in here, there's a few more functions, but really the two kind of relevant ones for 4.0 right now are squash and then SquashFS layer. So if we jump down to the documentation for this, you'll see this again, V1 image is this exact same abstraction defined by Google's Go registry package. And when I run this, given a base image, what this does is it returns me a new image where there's only a single layer. So if I go from the image that had 3 layers in that diagram, I run this on that, I will end up with a single layer image that's still in tar format. So one layer that's in tar format, and then the kind of second point here, the second API that's going to be useful is this SquashFS layer, which takes as input a layer and a directory, kind of a working directory, and then we'll spit out another layer. And this is useful to do that next step of going from a single layer tar-based image to a single layer SquashFS-based image, which has all the the great properties that we know and love from Singularity 3.0 that maps really well to HPC systems. So this is kind of where we're at. The next step here is really taking these APIs and wrapping them into something that's useful within Singularity. We're quite down in the weeds here, but just to summarize, the kind of flow here for Singularity converting an OCI image into a SIF image will be obtain, either an image index or an image from one of these sources. So often that's coming from a registry using a remote. We'll then manipulate that image. We'll squash it down to have a single layer in tar format, and then we'll convert that tar format layer into a SquashFS layer. And then finally, once we have that, we will use the SIF package here to write that out to a SIF file on disk. At this point, we'll have an OCI-based image. It'll have the same manifest and config as the original image, but the one or more layers that the original image had will be replaced with that single SquashFS layer that maps very nicely into Singularity and sort of our traditional way of representing images. So that's hopefully it was possible to follow that. I know this is quite, if you're not a Go programmer, this is quite down in the weeds, but that's kind of the summary of the work on the SIF side to encapsulate OCI images. Any questions on that or comments? All right, well, DT, I'll pass it back to you.
Thank you. What I want to try and do now is on the fly, while you've been talking, Adam, I've recompiled a work in progress PR, which is starting to use this OCI tools functionality that you described there to actually bring in OCI SIF execution into Singularity. So to start off, let's first look at a well, not the OCI one yet, but a Singularity SIF image of Alpine, which I pulled from the library. And here, this is the traditional Singularity SIF image where, as Adam mentioned, we have a squashfs file system visible. We've also got some JSON metadata and a definition file, which was used to build it. And in this case, it's signed as well. So there's a signature there. I've actually gone and used at this point in a sort of fairly manual way, the OCI tools code and the stuff that Adam was describing about manipulating layers and so on to create a file called alpine squash.sif, which is this OCI in SIF format image. So here we've got 3 OCI blobs followed by a root index, which was mentioned at kind of the start of what Adam was showing with the OCI tools repository and the SIF package in there. To show you what's going on behind the scenes and what's actually in this, we can actually use the SIF tool program to dump, starting with the root index. If I dump it into if I dump it correctly into JQ, we'll find that the root index here says that in this SIF file, we have a set of manifests, and there's only one. We've got an image manifest. So we've got some kind of JSON elsewhere, which is going to be describing a single image in this SIF file. And it's important to note this is a native OCI image. It's not a conversion or anything. So we can go and dump descriptor 3 in the SIF file, and it happens to be that image manifest. We see in the media type there, this is an image manifest. And the image manifest is saying that there's an image here, which consists of a config with a certain digest, and then a set of layers. And in this case, there's only one because the image was squashed. And we see that the media type of the layer is Sylabs image layer v1 squashfs, because it was converted from the kind of tar format into the squashfs using that mutator that Adam was talking about. And now if I dump number 2, we will see this time that we have a very simple OCI image config, which is just describing, in this case, again, what layers make up the root file system. And then if we had multiple, it would show kind of the order which they need to be assembled. And then when we run the container, it just runs bin sh, it's kind of the payload, and the only environment variable set is path. So this is very simple OCI image of Alpine, but we can see how this has been kind of taken from an OCI registry and then put into this SIF file. And if I am lucky and I run it as an OCI SIF in OCI mode using this PR branch, which I've been working on, then there we go. I'm inside the container. I can run my commands, and this is being run through a true OCI low-level runtime out of that CIF file with the rootfs coming out of a squashfs layer that is kind of encapsulated in there. So that's just what it looks like sort of more in practice once you apply the code that Adam was describing. Any questions on that? Hopefully it makes it a little clearer. Okay. So on the browser here, this is the PR I was talking about that's work in progress, starting to use this functionality. If you want to play around with it, please feel free to get that and build it and see what's going on. We'll be adding to this. Right now, Singularity doesn't have the means kind of integrated to create the images, but you have to use the OCI tools code somewhat manually to assemble them. We will be obviously adding the pieces to assemble the OCI CIF images properly very soon. Okay, other than that, we just have an item for any other development updates. I can tell you there's not a great deal more to talk about this month. We've had a few holidays, and also this OCI work has taken quite a bit of the time, as you might imagine. Looking forward to the next month, what I think you'll see is that the OCI CIF stuff is rather rapidly integrated into CE. And as we move towards Singularity 4.0 release candidate, we'll tidy up the remaining coverage of flags for the run shell exec commands in OCI mode. Those are going to be the main kind of things we focus on through the next month. I'll open the floor then. If there's any other questions or discussion or any topics you want to raise, please do so now.
I have a question.
Yeah.
So in 4.0, will the OCI mode be a default, or will it be still experimental, no longer experimental, or what's the plan for that?
Okay, so the intention is that at 4.0, this won't be experimental anymore. There will be the ability to either use the OCI mode by default, or to choose to use it only when the flag is specified. Okay, so we recognize that for some sites, the requirements of the OCI mode as they are today, which involve having unprivileged user namespaces enabled, which involve having the ability to provide new enough versions of fuse packages and so on, might be a blocker. And also there might be some concern that the OCI mode doesn't act entirely like the kind of prior native runtime. It acts more like the native runtime run with the compat flag, where the compat flag was intended to get OCI-like behavior. So we'll not have it experimental, but it will be up to sites to decide whether they want to have the OCI mode as something which is enabled as required, or whether they want to sort of transition to using the OCI mode as the default. The advantage there being that if you kind of move towards OCI mode as a default, then you are much closer to the behavior of other OCI runtimes, which you might use outside of an HPC environment. And in mixed environments, people are often building OCI containers and working purely with OCI tooling outside their HPC systems. So it'll kind of get you closer there. But like I said, I want to emphasize again, this will be something that sites can decide what the default is for their site. Any other questions? On the topic of defaults, actually, I'd like to invite, if there are any kind of thoughts about whether it makes sense for OCI mode to be a blanket default or to be something that an administrator has to switch on, or if there are nuanced thoughts about maybe that makes sense for places deploying new operating systems like RHEL 9, where you have by default username spaces on and so on, but it's not sensible on RHEL 7 where you don't have that by default. If you have any kind of thoughts on that and you'd like to give any input, then the GitHub discussions is a great place to do so, or you can drop by the Slack or on the Google group as well. We definitely would be interested in hearing any and all input there, because we do recognize that people will have different opinions on it, and we'll try and kind of satisfy as many people as we can. Any other topics? Anything at all anyone wants to raise? Okay, well, it's been a fairly quiet one this month. We should have quite a lot to talk about next month as we get close to a 4.0 release and things will start coming together. So I expect there will be quite a lot of stuff demoed next time. If you want to discuss anything that's been raised here, please use the thread for the community call on GitHub discussions, or drop by any of our other places. And we hope to see you next month at the same time on the first Thursday. Thanks for joining us.
Thanks, everyone.